You know, in manufacturing, there are a lot of reasons why you've got to think about surface preparation. There's preparation for adhesive bonding, conformal coatings, or even removing something objectionable like weld slag, debris. There are 100 reasons why you might need a clean, dry surface and need it cost effectively. I'm with Josh Robinson, he's Regional Sales Manager for ColdJet. Josh, those of us who worked in industry who've had to prepare surfaces for another process have had to deal with things like solvents, deal with things like grit blasting, shop blasting, and all these things leave either debris or something that has to be then cleaned in another step, if you will, before you can get to the point where you can move on to the next step. I understand at ColdJet, you've got something using carbon dioxide that really eliminates most of those disadvantages.
Okay, so yeah, we're using dry ice media to blast, and we're mixing with compressed air. So it's a non-abrasive form of cleaning. So we can blast over metals, plastics, and we're not going to damage them. So use sand blasting, use water blasting. You can alter the profile, and you've got a lot of mess to clean up. And dry ice blasting is a clean, dry process where the dry ice sublimates right from a solid to a gas on contact.
I've seen some processes absolutely involving weld cleanup or cleanup of, say, paste fluxes and electrical apparatus, where the problem is masking. You basically got, in some cases, an abrasive blasting operation where you need a lot of safety gear. There are environmental issues, of course, with blowing blasting media all over the place, and you've got to keep it away from delicate mechanisms on either side of it down there. Can you do away with some of that with this?
Yeah, absolutely. So with the dry ice, it's a soft cleaning process. So, you know, we avoid having to wear the whole safety getup. You know, we recommend you wearing a good pair of gloves, hearing protection, and eye protection. And if you're in a weld cell, definitely want to wear a smock, maybe a face mask, because you could get some of that spatter back in your face. But the dry ice will take all that off very cleanly. And again, there's no, sand going up in the air. You don't have to really worry about masking things off, because we can clean over 12 gauge wire without damaging the wire. We're probably not going to remove too much paint, because it's not a paint removal application. If the paint is failing, we'll take it off. But it will take off weld slag, greases, dust, all very well without doing any damage.
Now, in things like electrical apparatus, of course, the worry always, including things like switchgear, relay contacts, is what am I leaving behind that I can't get out? And
right.
That could be the safety hazard. If you're dry, can you go in there and maybe clean up contacts, for example, very deep inside a panel?
Yeah, first of all, you want to make sure everything's de-energized, obviously. But because the dry ice sublimates right to a gas, we're not leaving anything behind. So you're not worried about the sand sticking behind and creating that, not having the contact. But yeah, we can definitely clean that up very nicely.
Industrial applications is surface preparation prior to adhesive bonding, painting, any surface coatings?
Yeah, so it'll take off all the greases and the oils that you're looking to remove prior to painting. We actually call it environmental cleaning and surface prep. That's the major name for it. The dry ice, because it's non-abrasive, it will not alter the etch or profile, any of your metals or aluminums, anything like that. Wood, it will. I mean, when we're using it on wood, wood is softer than dry ice in the hardness scale, so we can go and remove layers of wood, but you want to do that to take away mold or smoke damage. But in terms of if we're blasting aluminum or metal, we're never going to etch or profile that.
Now, it's a compressed air process. Is operated on shop air?
Yes, we need a minimum of 80 PSI for all the machines, and then depending on which machine or which nozzle, you could be anywhere from 25 to 50 CFM or 80 for the bigger machines, 80 CFM for a low flow nozzle, 100 CFM for a mid flow, and up to 150 for a high flow nozzle.
Now, do I need a special type or grade of CO2? Can I simply buy dry ice from a local vendor and use that?
Yeah, it's readily available. For the most part, you're using blasting pellets. They're 3 millimeter, or they're called rice pellets, and they look like a grain of rice, and the machines, you put them in and we're going to blast them out. We can alter the size of those at the nozzle, and we do have certain machines that will take the pellet, nugget, or a block, and we'll shave that down to smaller microparticles as well.
According to Josh Robinson at ColdJet, consider a CO2 blasting technology when you need to prepare surfaces without residue and without damage to the substrate.